and welcome to the Teardown Sessions. I have an amazing show for you today. I've already been backstage checking out all the millions of cameras that we've got. We're going to have some pick and place action. We're going to get to see behind the scenes at a real assembly line from Cyber City Circuits. And we're going to get some piping hot, fresh, delicious boards straight off of that assembly line during our stream, courtesy of Joey Castillo, who's one of my favorite hackers. So I'm really excited for what we're going to share with you today. Before we bring on our guests, I wanted to give you a little rundown of what's been going on at CrowdSupply. So we've got some really cool things happening, actually. Let me change so we can have a look. So coming up on CrowdSupply, this is very exciting. We've got the Pixie Chroma from the lovely folks at Lixie Labs, some extremely flashy, colorful blinking lights happening here. So I'm really excited for this to start fundraising. But yeah, that's coming soon, so you can check that out. Another coming soon is another board from Peter Usden, who was a guest on the show like a few months back. And he has rejigged his popular icebreaker board into a teensy form factor. So if you want to add the Ice 40 into your designs, this is a really great way of doing that. So I'm excited about that one. That one's coming soon too. Another one coming soon that people are real excited about is the Caribou Light RPi hat. So a nice hat for a little Raspberry Pi there that turns it into a dual channel SDR. So lots of people getting real excited about the possibilities for the Caribou Light hat. And finally, another coming soon here is the project from one of our guests today is the wonderful sensor watch. It's very exciting. I'm not going to tell you too much about this because Joey's going to be able to show us actually what that looks like in person. We've got some of the prototypes to play with, so I'm really excited about that. Moving on from coming soon, we've actually got some things that are live now. We've got the Casio Stratus, which is a super powerful little board and a very small form factor. And it's got solar energy harvesting. It's got all sorts of really great things. So if you're looking to do IoT platform, I would recommend you check out the Casio Stratus. It's a good one. Closing soon, we've got the ATEC 1001, which is nearly there. It's at 76% with 4 days left. So now's the time if you want an SDR front-end pre-selector and you want to support this person's work from open source SDRs. Now's the time. A few days left to support that campaign. Also ending soon is the Chavi, which is this lovely little open source ESP32 fingerprint sensor. Happy to see that that's reached its goal with 6 days left. So if you want a fingerprint sensor, you've got 6 days left to support the work, the open source work of the team behind Chavi. And finally, we've got the 13 days left in the Kraken SDR, which has gone gangbusters. Everybody's very excited about this. Lots of SDRs this week, actually, and this one's doing real well. So we've got 13 days left to get this really very top-end phase coherent software-defined radio. So check that out. Finally, before we go to our guests, I wanted to share with you, we've put up a page now collecting all of the Teardown sessions. So you can see all of our previous streams. You can also see who's coming up. So today that's Joey, but we've also got another Joe, Joe on Joe. And then we've got Darian Johnson, followed by Bunny and Zobs, TBA. I haven't quite fleshed out the date with them yet, but that's happening in December. So we've got some really exciting streams coming up, and you can check out and also purchase some of the things that have been on the stream as well. So that's there, and you can also subscribe so you get the updates. So that's what's going on with CrowdSupply. I'm going to remove that from the stream. Before I bring on our guests, of course, there is the weekly hardware mystery box giveaway in our Teardown lunchbox, which everybody loves. Very exciting lunchbox, and this is stuffed full of swag, and there's 2 pieces of hardware in there this week. And the way you can win that is by commenting, please. So please, while we're here shouting into our void, our computer box, please do comment and say things. You know, we love to hear from you. We love to hear your questions, anything that you want, even if it's just very frivolous. You're very, very welcome. We love participation. It makes us feel like we're less alone. And to show that we love participation, we will be giving away the mystery box of hardware to the person who comments closest to the timestamp on this piece of paper, because that's how we're doing it. So So without further ado, please join me in welcoming the delightful, here we are, let's change it to here. We're going to add in Cyber City Circuits. Hello. And Joey, do you want to unmute yourself? There, I did it, don't worry. And then let's add in one of my favorite ones. Look at this, live from the assembly line. What's going on there? Hello, guys. Thank you so much for joining us. It's really awesome. I'm so excited to get to actually see inside your space there at Cyber City Circuits while you work on Joey's really awesome sensor watch. So while we get, let's kick off and say, hey, can you introduce yourself? Joey, let's start with you. Do you want to introduce yourself and tell us how you've been working with Cyber City Circuits? And then,
sure. So yeah, I'm Joey Castillo. I'm a software engineer turned kind of hardware hacker type person. I've been working on like a while ago I was working on this project called the Open Book, and I wanted to play with I wanted to learn more about manufacturing and like the whole design for manufacturing kind of thing, and wanted to do a simpler design that could teach me some of those lessons. And so I came up with the sensor watch, which is a relatively simple but incredibly powerful little board that fits inside of a really, really tiny Casio wristwatch. And so I've been, hacking on this since January, doing a lot of things by hand. At one point, I live streamed myself assembling a board of 17, and it took me over 3 hours. But now I'm here at Cyber City Circuits, where we are assembling, 10 boards in under 10 minutes. So that's very exciting.
I can't wait. We're going to do that live, by the way. We're going to do that live in the stream, aren't we? That's what I've been promised. Anyway, we're going to actually get to see the pick and place machine work, and then we're going to get to not quite smell the fresh boards, but we can imagine. You can describe it for us. And what you do, and do you want to introduce yourself?
Yes. Hey, I'm David. That's Chris. We got Angel over there. He's going to be running the camera a little bit later. We're Cyber City Circuits. There's 6 of us.
Wow.
We're the largest electronics manufacturer in Augusta, Georgia. No big deal. And we do electronics manufacturing, or small businesses that works with other small businesses. We work with small businesses that have hardware electronic needs. We offer design services. We offer manufacturing services, fulfillment services. We're basically, if you have a hardware tech startup, you need a manufacturing department. All hardware tech startups start out with just 1, 2, maybe 3 people, right? They don't have the infrastructure needed to actually accomplish their stuff, and they make a lot of mistakes along the way. We help you. We help you along the way.
Quite a lot of like indie manufacturers, like on through Twitter. I've seen you have done quite a few hardware campaigns with people from the community, or hardware manufacturing.
Absolutely,
the community.
The really Twitter community has been amazing when it comes to this stuff.
We love it. We love the machines too. All right. So first of all, before we get any deeper, so thanks for introducing yourself. Before we get any deeper, I want to just take a look and see who's joining us today from the internet. First of all, we've got the first person to comment was I Shot JR. Hello, it's really nice to see you, Dave. Always good to see you, man. And then we've got Benjamin Ward saying heyo. Straith is here from Great Scott Gadgets. She says hi, friends. Oh, and Jason's here as well. Nice to see you, Jason. Hi. Of all the blinking lights, beautiful. Yep, and you've got the Bunny's book on the shelf. Of course, Bunny was one of the people who was instrumental in finding Crowd Supply. The fact that not a lot of people know, actually. So Bunny's done a lot of stuff with us. In fact, I'm excited to welcome him onto the stream soon. Straith says that she's really excited for this Teardown session. Me too, Straith. I'm super excited. I keep looking at the pick and place machine, hoping it moves things. And she also says that she's backing the Pixie Chroma as soon as she can. Yeah, you and me both. Like, it looks so cool, right? Really, really, really nice. And yeah, we want to back all of these. Please send help. I mean, the struggle is real. Unfortunately, I don't get like free, unlimited free campaign goodies, or I'd probably just have a house just filled to the brim with all the stuff that we make. Then we've got, who else is here? We've got Wesley Aris in the building. So hello, fellow void shiters. Hello. We got the echo back. But there we are. Helen responds, it's not just a void. It's a very companionable void. We're all shouting at each other in the void. Yeah. And Jason saying, hi there. It's so nice. And so hyped to see the sensor watch teaming up with all my faves. Crowd Supply, Cyber City Circuits, Sparkle heart, my favorite emoji. But I'm glad that Crowd Supply is one of your faves there. Feeling I enjoyed the compliment. Thank you. Straith has asked, there's a question already. Straith has asked, will you give tours someday to Cyber City Circuits?
We do. We do tours periodically. You're great. This is Great Scott Gadgets. That's a long plane trip, but you're welcome to come.
Yeah, for sure. Great. It is a lot. It is quite far, actually. We've also got Rohan Singh, who's here saying, can't wait to see this pick and place in action. Me either. And then who else have we got here? One more person there's new. Bradan, I think it's pronounced, Lane, saying so many familiar names in the chat. Big hello out to CCC. Now, for me,
so this gentleman did the
computer club. So, but I guess it's also Cyber City Circuits with an American accent, not a German accent. All right, so thanks everybody for saying hi. We've got a nice crowd in there. We've got quite a few people come in to say hi to us, which is great. So please do keep your comments coming, especially if you've got questions for our guests. We'd be really happy to interrupt them and ask them all the things that you are desiring to know. Anyway, let's move on and talk a little bit about what you're actually making, Joey. So it's not just some random thing that's going to be going on the assembly line, is it? What are we going to be making today?
So in particular, we are making the sensor watch. This is a so I know you may look at this and be like oh, it's just a old Casio wristwatch. It is actually this board that goes inside of that wristwatch, and this is a board that I've designed using the Microchip SAM L22, which is
there we go.
Okay. Yeah, the SAM L22, which, if you're familiar with the SAM D21 or SAM D51, it's a kind of a not dissimilar chip to that, but it has an LCD driver, which allows us to use this kind of like flexi ribbon connector. Well, we call them zebra strip connectors. But basically, it's how you connect a classic LCD like you would have on one of these wristwatches. So you get a lot of the peripherals you would have in the kind of SAM D series chip, but you get it in a really low power package that fits inside of a watch that goes on your wrist. So that is actually, if we wanted to spotlight the little the window that I
your down camera, yeah, I can do that. Yeah, let's do that, and then look at that, perfect. Oh, so nice.
So this is the kind of close-up version of the board, and actually, I've got one here that I'm really excited about. I didn't even realize I could do this until recently. I've taken the backing off of the LCD, so you can see inside. That's actually the inside.
Oh, that is so dope. This is so cool.
Thank you. This is one of these circuit boards this is actually the first circuit board we assembled. We assembled it last night just to make sure all the settings were dialed in. And so you can kind of see in there the blue circuit board, the quartz crystal down here, microcontroller. And this is actually on the board. You see these this little flexi connector. It allows you to plug in different kinds of other sensor boards. So you can actually, in addition to all the parts that are on the watch, you can add additional sensors to it. So in this case, this is a prototype. I'm not sure you can read in there, but it says sensor watch motion, and it's my prototype accelerometer board.
Oh, wow.
I haven't quite finished the code for it yet, but when I get there, the idea is it would be able to wake up on motion and possibly do step counting, that sort of thing. So yeah, I thought that was really cool. You could just see inside the board, and it really is a gadget forward kind of look.
I really love the transparent backing to electronics. The Reform laptop has got a transparent underneath. So you can flip it over and look at all the things on the inside, and I just love it. I love seeing my electronics.
Totally.
Super cool.
Yeah, and in this case, it's not the most readable watch, but I mean, it does look pretty darn cool.
It does look really cool. And how many can you fit? Can you fit more than? How much can you fit inside of that body? Like when you strip out the is it like the main board and then a sensor attachment?
It's pretty much the main board and the sensor attachment. So the main board is about yay big. And the area you have for sensors is just kind of this little area to the left of the processor here. We cover up those test points with capped on tape, and then you can just put whatever you want in that little, 5-6 millimeters square area. So that one has my prototype accelerometer. This one actually has a thermometer. It's just a thermistor kind of voltage divider in here.
Nice.
So it's going to read the temperature every 5 seconds and kind of maybe show my my hand raising the temperature by a fraction of a degree. And I actually
I like the overlay you've got there as well, like the sensor watch. So you got is that like printed vinyl? Is that or what is that? Is it a sticker that you put on top?
It is a sticker that I printed on my parents' laser printer back in home.
Nice. I like it. I like the font as well.
Thank you. Yeah, it's actually I realized the Casio logo. I think it's in the same typeface as all of the HAL 9000 systems in 2001: A Space Odyssey. It's a very classic font.
Delicious. Oh my goodness, that's a good fact.
Yeah, it's fun. I just put this way so people look at me like I'm crazy when I say, no, I made this watch. No, you didn't.
Like, sure you did.
Sure, yeah.
Sure, Joey.
Anyway, the reason that I built this one with the temperature sensor is actually, it's not the most useful thing on your wrist, but what I like to do is go backcountry camping. And so my thought process is, and I've done this before, going backcountry camping, throw the watch outside the tent overnight, and it actually logs temperatures all night long. So this is the temperature at 2 p.m. I can go backwards in time. It was on my wrist, but
talking about this, okay, so there's one thing about this watch that kind of blew my mind a little bit when I first saw it on the internet, was the 1 year battery life that you've managed to get. Can you, like, is that real? Is that tested, or is that just assumed? Like, what's going on?
What's going on? A year, yeah. So what's going on is that a couple of things. One, these little LCD displays, they take very little power. So I'm actually, this is probably a good opportunity to mention, I'm going to be giving a talk next week at Hackaday Remoticon talking about LCD technology and how to like reverse engineer some of these LCDs to make them do the things you want. But one thing that I learned working on this, so you imagine those like kind of like 7-segment LED displays with like the very classic retro pinball machine look. They light up when current flows through the LED and it makes light. These screens don't work like that. You can almost imagine this LCD screen as a capacitor, where there's a difference in charge across the segment, and that difference in charge causes it to change color. But the actual, like, no current actually really flows in between them. So you can like keep refreshing this display, but it doesn't actually use a lot of current. So that's number one. And then number two, this Microchip SAM L22 is really designed for low power usage. And I'm not sure if I might have already turned it off a little bit. There's a low power mode it goes into where the seconds don't tick like this. They just kind of tick a little animation like a tick-tock. Yeah. And once it's in that mode, the only clock running on it is a 32 kilohertz crystal. So it's using something on the order of 9 microamps of power.
Whoa.
Which is a really small number, and it lets you take this, this CR2016 coin cell and really stretch it out. So this watch is actually also running my.
It runs on a coin cell.
It runs on a coin cell. It runs on it runs on the same coin cell that comes with the watch. You can take your original Casio apart, put the coin cell it came within, and it'll just work.
Nice. I've not seen a board using the SAM L before. Is it quite a new chip, or is it something that's been around for a while, but it's just not as?
I believe it's been around for a few years. It's definitely hasn't had the kind of popularity of the SAM D series. But it's a really great low power chip. And again, that LCD controller is just a really unique feature. And I mean, I'd like to see more people using it. I feel like I'm seeing more people using it of late. Dave Darko's doing a fun watch mod with nice. SAM L watch.
I love Dave. We used to be in the same makerspace together in Berlin.
Oh, right on. Very cool.
Dave and I have hung out quite a lot. He's a delightful human being. Makes all sorts of cool things. I've got loads of comments. I've been too excited by the watch to actually even tell you what people have been saying. I've been a terrible host. So like everyone's very excited. So everyone loves the clear transparency. They want a clear case for the clear screen. and there's plenty of people who really like that. And Wesley was like, oh, I really want a purple translucent case. I think there's going to be. I can imagine that there's going to be quite a lot of DIY cases being built out around this thing. Oh, Ali is here. Hello, nice to see you from SparkFun. Yeah, nice to see you, man. Good. Thanks for dropping by. Jason says, yes, it's the ultimate electronics nerd watch. I can definitely, I agree with you. And Benjamin appreciates the style that on the old mechanical watches, that it looks really awesome. And we've got a question here saying, what was the first digit to the left of the 9? Oh, so do you want to pick up that watch again?
Yes.
Because I think they're referring to the fact that you've got different characters, right? So you've not. Yeah,
let's see if I can get the temperature to go down again. Yeah. But basically the Casio F91W is designed to show just the time in that line, or a stopwatch that goes up to 59 minutes. So they never intended for that first digit to contain anything other than a 1 through 5. So it can't display the number 7 in the same way that the others can, because the top and the bottom segments are linked together.
Oh.
So to get around that, I've made a.
That's so interesting.
I can wrap it around my iced coffee and get it to go down. But I've kind of used a lowercase 7 to get around that limitation. So yeah,
you've done a little. Okay, yeah.
The 7's a little shorty.
Yeah, that's really cool.
Wait, actually, I can just go to the next screen. That's what I can do.
Might be a good time. Oh yeah, here we are. Look at that. Yeah, so that's a 7, is it? So it's 76. That's meant to be.
Yes.
Okay. We want to come back. I want to come back to this.
Yeah.
I want to know, but I definitely want to come back to how you've managed to program it, and put your own special characters in there, because I know that there's been some really interesting things that you're doing, and also I want to learn how to program it myself. But we're gonna first, before that, we're gonna keep looking at some of the comments. Straight saying, "Are you worried about raccoons stealing a watch that you leave outside?" Well, I mean, I don't know if you have.
I don't think it's made of food. It's made of toy.
Yeah.
I was going to say, should we start the pick and place? Should we get?
Oh, that's a good idea.
Rolling?
That's a really good idea. Yeah, let's hang on. If I remove.
So we can show you part of the process. Do you want to do the stenciling first?
Yeah, we can go through the whole process.
Yeah, let's do the whole process. Hey, can you hear me?
Yeah, I can hear you fine.
I'm David. That's Chris.
Oh, that's really cute. Yeah.
Hey, Angel.
All right, which one are we? Oh, we're doing these 4 now. Okay. Oh, look, here we are. Yay! Assembly line.
Yeah.
Assembly line.
So let's here. I'll take that.
Talk us through what's happening.
So we have this inexpensive, heavy, fancy machine right here, the stencil printer. Now, solder stenciling, that's the part where like the solder paste gets smeared onto the board very selectively.
Hang on, I'm going to spotlight you on this one.
And so what Chris is going to do is he's going to hit the button. And it's going to smear the solder paste through the stencil. Just like that. And then he hits the button and it pulls up the stencil. Oh, he's going to do a second pass. I'm going to lift the stencil.
Nice.
Board. Now this board is a panel. There's 10 boards on this panel. And it's 0.6 millimeters, itty bitty, super thin. So then he's going to set it in the tray. And we'll go over here, where this one's already set up.
Oh wow, that's cool.
And then we got to go dark. We have to go dark because the camera, the up-facing camera, doesn't like the lights in our ceiling. So this is a Shanghai CHMT 48BB pick and place machine. It can do 0201 just fine, which we found out recently. And we have 3 of them. So and it can do tube, it can do tray, it can do reel, it can do cut tape, and it works fantastic.
Is it valid when it goes over that light? What's it doing over the light? Is it validating the piece that it's picked up?
So it is. So it uses a camera to verify that it's picked up exactly where. That way, it knows where to put it on the board perfectly. Okay. So it knows where the pads in the Gerber file for the PCB. It knows where the pads are supposed to be. So it takes pictures of all the parts while it's on the nozzle, and then make sure it knows where the sensor is.
Nice. Really nice.
So this will take about 10 minutes.
This will take about 10 minutes. This because of bomb count, the speed. We had to slow the machine down some because the boards are so thin. This will take about 10 minutes to do all 10 of these boards in this panel, and then it'll go through the oven. So we can leave this running a little bit. This will take minutes.
Yeah, that's really cool.
Keep talking, and
I've got a question here from Ali from SparkFun has asked how does it know where the pads are supposed to be?
So there's a position file that you can generate in Eagle or KiCad or Altium, your EDA software, and then we convert that to a proprietary format file that goes into our machine. And that has all the positioning, all the XY coordinates, all the angles for all the parts and everything.
That's really interesting. So it's verifying it, but it already knows where everything is, and it knows how many boards are on the thing, so it's then able.
Right.
And then what's the so it's picking and placing. It's putting all of the different components from different places onto the board, visually verifying them all. And then once this is done, what's the next step? So we've got the solder paste.
So after
on,
this, there's going to be some.
You put the solder. You've printed your PCB boards. You've spread solder paste on them like butter through your stencil. You put them into the machine. It pick and places them, and then what happens?
Well, so next, there's going to be some hand placed parts. So there's a connector that we have to hand place because the machine won't place it. The machine won't place every single part. So we have to hand place this part, and then we'll put it, roll through the oven. We use a hot plate to keep everything warm. It helps get the solder all nice and juicy. Because, and then we use the oven to get it up to that flash point so all the solder paste can melt. Yeah. And then it'll just go on a cooling rack until it's cooled off. And then Jason will get them, or excuse me, not Jason, Joey. Joey will get them, and then he's going to program them and test them. And he has one right there that was already finished, right?
I do, yes. I wasn't sure.
Let me add that in then.
Yeah, I can go hand place some parts.
Look at that. Okay, so this is one that has been sold. It's been solder stenciled. Everything's been placed on it. The things that needed to be done by hand have been placed on it. It's been baked to get it all to melt and stay in. So, and this is the result, right?
This is the result, yes.
Okay.
So actually, Chris is over there. There's a board that he's going to place some parts by hand. I'm not sure if that camera is up.
If I go into, let's have a look at this assembly line thing. All right, look at that. I've spotlighted you so we can see the hand-placed parts. What are those hand-placed parts? Sorry, I know you told me, but I forgot already.
Yeah, can you hear me or no?
Yeah.
Okay,
yeah,
great.
I can hear you.
Yeah, so those hand-placed parts are the flex connector.
Oh,
so,
I see. Yeah.
And I was chatting with Chris about this. This is a part that the machine could pick and place, but in our case, we just decided that it requires a little more dialing in because there's that big gap in the middle. You'd have to adjust the center point for pickup, and you have to adjust the center point for dropping it. And for a small run like this, it made more sense just to hand place them. So in this case, that's what we're doing. So this is the one last step before we put it in the oven. Chris will hand place these flex connectors, and then they would go in the oven.
Very cool, very cool. I've got some questions here from people who are watching and comments. So Radan says, pretty cool to make it watch the tiny adjustments based on the camera. Yeah, it is true. That is really cool. Straith says, juicy solder. That's delicious. Have you ever seen those like solder machines that they're like fountains of liquid solder? I forget what you call that method.
Wave soldering, maybe?
Yeah. And there's also one the condensation-based solder, which I wasn't aware of until relatively. Like they condense. It's a really wild method of soldering that I've not seen before. And so Ali also asks, how do you align the board properly? Is there just an end stop, or is there a camera on the pick and place end piece? That's
a great question.
Yes, it is.
And Benjamin pointed out that there is an end stop, but also because of the manufacturing process, not the edge rails, the panelization isn't perfect every single time. And if it's off by like a fraction of a millimeter, that's a big deal, right?
Yeah.
So we have to manually calibrate each board.
Yeah. Wow, that's wild. And then we've got I shot JR. David says, since we have 10 minutes, can it only do temperature, or are other sensors possible?
For the watch, I take it?
Yeah.
So I designed I borrowed the idea for the 9 pins that I've assigned to this board from an Adafruit design called the Monster Mask, which, but basically this board supports I2C 5 GPIO pins, power and ground. So with that, you can do like the temperature sensors, if they're Mr. Virtual Voltage Divider. I've got one waiting for me in New York that does, hopefully, fingers crossed, a photo transistor for a light sensor circuit. But it also can do I2C sensors. It can do SPI. So if you have an SPI-based chip, you can. I'm hoping to. I've got a flash chip. I can at least read the chip ID off of it. But I'm hoping I can use that for big lookup tables. I like the idea of imagine like having your city's mass transit schedule all on this Casio watch and being able to say when is the next train arriving. So you can do other kinds of sensors. I'm curious to see what folks will come up with, because I've come up with some ideas, but I'm sure that there are all kinds of people have all kinds of ideas.
Yeah, for sure. I'm sure they will. I'm sure they will. We've got, oh yeah, that's it. Thank you. Vapor phase soldering. That's exactly the word that I was looking for. Yes, that's one that I've only recently learned about. I was like, oh, that's cool. Yeah, okay, thank you. Thank you there. Thanks. I shot JR, who apparently straight says, I read your name as is hot JR. Thank you for saying that, Straith, because do you know how long it was? It was probably over a year that it took me to realize that it was I shot JR, like that Twitter handle. I felt so dumb when I realized what it was, but it was all run together. So I thought it was also like some weird like hotness thing. So yeah, and then Ali from SparkFun says, what about a double-sided board? How in the world do you place and cook both sides without having components fall off? Great question.
This is a great question. Science. So there's surface tension in the solder.
Yeah.
And it doesn't seem to matter. They don't seem to care that they're upside down.
Wow.
The solder, if you solder one side, you flip it over. Now, some parts you can't run through twice. Yeah. Or you want to be careful when you run through twice. Like some plastic connectors and things like that. But really, the surface tension of the solder just holds everything in place. As long as you don't jerk it around, it's going to be fine.
Yeah. I had no, do you know, a great question. I didn't actually know that. I've never done a double-sided board before, so great question. Thank you very much. Science, yeah, see, we love it. Science. I have a science, mind blown. And then Benjamin says, also glue sometimes.
So since someone brought up the subject of glue, don't ever use hot glue in a soldering project. It turns into tear gas. It vaporizes in
super glue, not
super glue. Oh, not hot glue. Super glue.
Not
Now say hot glue. I use hot glue in every electronics project.
I was there like,
glue.
oh no, I've done some bad things. Probably in some classrooms as well, because I've definitely used hot glue guns in the proximity of soldering before. That's so funny. Sometimes I keep things in place with clear nail varnish, actually. That's my soldering, because it sets quite nicely.
So right now, Chris is calibrating the next board. That's what Chris is doing. He's so cool. The machine will pick one part from the upper left-hand corner of the PCB, the lower left-hand corner, and the lower right-hand corner. That's what he's doing right now. And then he'll pull the camera to that spot, and he has to find the center of those parts.
Oh yeah, so I see that.
And then if he gets it right, then everything goes smooth and everybody's happy. If he gets it wrong, then everybody's miserable. So luckily, he's pretty good at it. Yeah.
Amazing. It's so exciting. Stray says that she's learning so much about solder today. Yeah, me too, actually. It's always good to learn. Always good to learn. And now, here we are. Another person who's repping clear nail varnish. I keep a bottle of clear nail varnish on my workbench. It comes in handy all the time. And Bradan has asked if the PnP is able to pick up parts from trays.
Yes, it is. I'm sorry.
That's all good. That's all good. Very cool. And we've got a comment here from David saying, I've never seen this much detail of the PnP process. That machine is amazing. It is really cool. I've got to see quite a few awesome pick and place machines. I actually got to press go on the pick and place machine at P. Maroney once, which was great, which felt amazing.
So right now, Chris is about to, like I said, we preheat our boards on a hot plate. So he's using a thermal thermometer
spotlight, yeah,
to tell what the temperature is, and it's going to put it in the oven.
Nice.
And it's a lot more like baking than a lot of people might realize. So you have to preheat everything, pre-soak. Isn't it cool how it picks up that QFN chip? That thing is a monster. It's huge.
Super cool. It's super cool. Yeah.
And sets it down.
Really cool. Ooh,
so, I think should I just flash the boards now? Is that the next step in the process?
We got them in the oven. Sure, let's go. So that's the next step in the process.
One more question that I wanted to ask before we do the flashing, because I think it's time. I think it is time, definitely. So we've got Benjamin has asked, you mentioned you could play SO201. Do you have a write-up of how you've managed that? I've not even been able to get close with my 36VA. Barely.
Your 36VA can do it. Message me on Twitter and we'll talk about it.
connecting people and
Right.
sharing knowledge. That's what.
But your 36 VA can do it.
Amazing. Really, that's awesome. Okay, Joey.
All right.
Should we do some should we do the next step in the process?
Yes, I mean this is kind of the
tour of what happens when you assemble a board, but it'd be really good to see what happens next.
This is the penultimate step. So if we're gonna go to the down camera, I can.
Sure. There we go.
So this is the batch of boards.
Rule.
It's the Circuit Python ruler. This Pi ruler is a crucial part of my build steps. Yes, I am not joking. So I have this pogo pin connector that I've just designed with literally just a simple cable housing and some pin headers and some pogo pins. And yeah, I'm going to put this on my programming pins, hit reset, and hit reset.
So talk us through what's happening here.
So what's happening here is this Pi ruler has on it an Arduino sketch that just has the bootloader code and uses the Adafruit DAP library to talk to the chip on this board. So when I put these pogo pins down, that powers up this watch board from the Pi ruler, and then the brown and orange pins are SWD and SWC. Which did I break this sketch right before the stream?
It's possible. David, so we've got a question saying, is each pogo touch doing the entire flash?
Whenever I press the reset button, it should be flashing it. But I recently recompiled this because I got a new USB VID PID combo, and it's possible that I need to go back to Arduino land and fix this. Oh, there it goes.
Oh, look, here we are.
Yeah.
All right. That's really quick, actually. How long does it take? How long do you have to hold it down after you press reset in order for it to flash?
It should be a fraction of a second.
Really?
There we go.
What's on this? People are very excited by the Circuit Python ruler, which is not the point of the stream, but I do have a Circuit Python ruler, and someone's asked where I got it from. I'm like, I have no idea. I can't remember where I got my Circuit Python. Probably some kind of bag in some conference somewhere.
I got.
Where'd you get yours?
I got mine when Adafruit made a bunch of them, and they were giving away for free with orders. But I got to say, it is a crucial tool to flash firmware onto devices. And you can also measure something with it if you haven't. If it's not too much a part of your build process, you can actually measure things with it.
Tell us what's on that Pi ruler board. What chip is it?
So the Pi ruler, this is Adafruit's board. It's a SAM D21E, which is a very low pin count version of the SAM D21. But yeah, Adafruit has their Adafruit DAP library, which they use internally, I believe, to flash all of their boards and do all their testing procedures. So they're just kind enough to provide it to the community, and I'm able to use it here with my sketch to burn the bootloader on these watchboards.
Yeah, super cool. I wonder if they still sell it. Why don't you explain some more, and I'll Google if you can still buy it. It's Python, right?
It's Python. It also supports Arduino because this is just an Adafruit trinket on the ruler itself. So you just use the trinket core, and
you can buy
the Arduino cord will work.
I'll drop the link in the stream. I always need an excuse to do one marquee banner per stream. Marquee. So
yeah, at this point, I believe all of these boards are flashed with the bootloader firmware, and so the next step I can do is just I'm going to plug this. That's the other cool thing about the sensor watch circuit board. You can plug the circuit board itself directly into a USB port. So here, I'm just going to take this USB plug and plug it directly into my circuit board. And there it is. And so now I can just tab over to my Finder here. Oops, not knock over my laptop.
Let's try not to do that.
And yeah, if you look at the left here, there's a drive called WatchBoot. Oops, WatchBoot. And WatchBoot has the UF2 bootloader, where if you look here, it's the Sensor Watch M0.
Nice.
And you just drag current.uf2 right now is blank, but that's whatever code is on the watch right now. And so if you wanted to drag the code off and put it on someone else's watch, you could just drag it from one drive to the other. Or if you want to build your own code for it, you can just build a UF2 file and drag it onto this, drag it onto the watch with this bootloader.
Amazing. Super fun. Super fun. That's really cool. Do you want to show us? This might not be the time, so you can say no, but I'd love to see an example of some code that's gone on to your.
Absolutely. As a matter of fact, Wesley is in the chat here. He just wrote a stopwatch applet for the watch. He has one of my beta testers has been prolific. He wrote the beat time application. Right. Let me see. I can share my screen.
Yep, you can share your screen and I'll add it in. That one, so I can get you. Yeah, just let me know when you've shared your screen and I can add it into the stream.
Oh. Share screen. I'm sharing.
Oh yeah, link to GitHub. That's a good point. Yes, let me find the GitHub link and then I'll share it with everybody. Because I think this project in particular is going to be one where people really want to get involved, right? People want to make their own code. People want to code their own sensors. Like everybody wants to use different sensors. And I
certainly think so. Yes.
Yeah, it's definitely going to be a group effort. This watch is a group effort for sure. Let me find your. Can you?
I'm trying to find the window I want to share.
Okay, that's fine.
Where are you?
Hiding from you.
I have too many windows open is the problem. Visual Studio Code. Okay, movement config.
Try and find the code in the tab somewhere. It's hiding.
There we go.
Okay. All right.
Then you see it now.
Stream. Here we go. Ooh, yummy code. Delightful.
So
talk us through what's happening here.
So there's. Let me actually go to a different one first. So at first,
I'm going to find your GitHub as well, so I can share it with everybody.
Oh yes, absolutely. So initially I wrote a library, a watch library, and the idea was you would implement your application by just implementing these 5 functions: app init, setup, loop, prepare for standby, and wake from standby. And that's really great for some very basic kind of apps. The BME 280 was the one that I took hiking, but the starter project is a good example where you initialize the app by just creating your application state, and then you have a setup where you can enable this is the LEDs and the buzzer, and you set up what you want the buttons to do. And then you have a loop function where you just say, if you want it to beep, beep. If the light needs to be on, turn it on. You can just say, watch display string to display a string on the LCD. Mm-hmm. So this just swaps between hello there over and over again. And that's kind of the way that you would write a very basic application for the watch. But since then, I've kind of worked on a more advanced firmware for this, which is what Wesley was writing his app for. I call it Movement. And the premise of
your accelerometer app, or
I was thinking Movement in terms of people call a watch movement the thing that actually drives the internals of a watch. I don't know. It felt punny in my head.
Yeah, I like it.
but the premise behind this one is that all of that kind of homework of dealing with making a run loop and setting up application state would kind of be handled for you, and then you can just write a much simpler kind of application. So let's go to the beat time actually. So you still have these kind of setup, activate, loop, and resign things, but you basically create your watch face, and it kind of slots in with other people's watch faces. So when Wes did the beat time application, he created his setup, activate functions. His loop just has to handle these events like ticking, like low energy updates, like what happens when a button gets pressed. But that's it. That's his entire beat time app. Only has to be 77 lines of code, because there's other watch faces that handle things like setting the time or setting the watch settings and going between faces and things like that. So that is I'm just gonna hold up the watch. You don't have to switch any screens or anything. But did I lose the watch? There we go. So when
Raccoon has stolen it, I think.
It's all good. So when you go to this beat time watch face here, which you can see in the sidebar, that application is running, and that's the watch face that it's active. But when we press mode here, now it's the temperature face, and the beat time face isn't active at all. So that's kind of how I imagine people will start writing code for the watch. They'll be able to create their own watch face, and then in this config file, it's just a list of watch faces. So which watch faces do you want? For the transparent one I made this morning, I wanted the beats face, the stopwatch face, and I wanted to show the battery voltage. So yeah, or in the character set. So yeah, you can just kind of create, mix and match with whatever firmware you want and have a very customized watch for exactly what you want it to do.
It's such a cool hack, man. I have to interrupt you for a second because I completely forgot. I got too carried away watching your code. I completely forgot that the timestamp for the Magic Hardware giveaway has passed. Let me just that for a second so we can actually see. So this is our box full of delights, and on the time was 12:42, and the first person to comment after 12:42 was ishotjr.com. So you have got a bag or a lunchbox full of goodies for you whenever you want. So just DM me your address and I'll sort you out. So inside this week, what have we got? What have we got inside this week? It's always the obligatory, very attractive Mauser baseball cap. we love our baseball cap. We got some stickers. We got some booklets. We've got an Arduino proto board here, and the major piece here today is the Hearty Patch, which is a great little device that is for ECG monitoring. So you've got all these fun things, so you can actually start playing around with heart monitoring. So you've got that on the way to you. Just DM me your address and I will send that out to you on Monday. It comes with its own USB cord as well. Very exciting. So yeah, a Hearty Patch, which of course is open source as well, a hat and a proto board on the way. So thank you very much for participating. And of course it comes in this delightful Teardown Session box as well. Okay, so congratulations, David. And let me know your details and I'll get something to you. Okay, so back to you, Joey. Oh my gosh, hang on, wait. We got to take, sorry, Joey. We got to look at what's going on the assembly line. What is happening?
It's newborn sensor watch boards. Here they come.
Ooh, babies. I'm going to spotlight them. We got to watch them. Oh no, we got to watch them emerging into this world.
Right.
Hello, it's so nice to meet you. So cute. It looks like a toast rack.
It sure does, doesn't it? So, they're great. Once you get it tuned in, they work fantastic.
Are they delicious?
Well, I think so. They do resemble little crackers, like little snacks.
They do.
Yeah, they do look like little snacks. Is there any kind of smell?
There is, but we have a vent hood and we suck all the fumes through a charcoal filter. Very expensive charcoal filter, and it works fantastic. And we change it out like once every 6 months.
Okay.
I gotta say, like, having done a lot of I do a lot of building stuff myself. I feel like I detect no fumes when I walk in that room. Like,
really?
Yeah, it's a very effective filter.
That's great. Yeah, the scent of
if you forget to turn the vent hood fan on, then you start smelling it. So that's how we know that it works really well, because you don't smell any of it when the vent hood's on.
Oh, lovely. Okay, let's check in with what people have been saying, because I've been neglecting our people who are here. Oh no, I haven't. Oh yeah, so we got Brett Graham has said, are there any plans for Python support?
So deeply, yes. I've tried a couple of times to port CircuitPython over, but my master of the CircuitPython internals is not quite where it needs to be. Okay. Which is why I kind of went back to working in C for a while on this movement firmware. But I desperately want CircuitPython running on this thing, because CircuitPython now has support for timer interrupts, and I think they're actually trying to do they do have an alarm interrupt now, don't they? Like a pin interrupt. Anyway, I really want CircuitPython running on this, because I do think you could probably get a significant amount of battery life out of a watch running Python on your wrist, which I think would be just amazing. Yes.
I agree. So here we have, look, if anybody is an expert in Python, here is the GitHub. You can get involved, please. It's definitely a community project. So yeah, okay, great. So you're looking for people to help.
Yes.
Yeah, amazing.
Well, and that's my hope. Once this campaign gets underway, and you get real hardware into people's hands, it gets a lot easier.
Yeah. Then we've got an Ant's question here. Is there an emulator, or are there going to be plans for an emulator for people who don't have that device?
So James Bowman of X Camera Labs was working on an emulator, and he has cooked up something. There's a demo of it. I believe he's needs to kind of like incorporate some of the more recent changes to the watch library, but that is a goal also. Yes, and it's something he's been working on. So thanks to him, kudos to him.
Super cool. Oh, we've got a comment from Drew. Hello, Drew. Nice to see you. Not that I don't see enough of you at home. But Joey, the use of PCB palette on that recent watch face board was amazing. So
thank you.
Yeah, really
I'm not sure if everyone knows. Like, when I was brainstorming a sticker to go on the front, I came up with a kind of a vaporwave color version, and yeah, the purple Osh Park PCB palette was definitely an inspiration.
Yay! We love it. We love it. We love it. Straith has asked, do you all have aprons for when you're cooking boards? If not, you should.
No, we don't.
No,
that's not a bad idea, though.
Yeah, that's not a bad idea. Not a board. Oh, we've got a question from Jason. Great, Dave. Have you cooked up any of my Fibonacci boards recently?
For the people that don't know about Jason Kuhn and his world famous
Jason Kuhn.
Fibonacci, well, that.
Come on.
Straith lady doesn't know.
Amazing boards. Amazing.
Great Scott Labs doesn't know, so we're going to educate them.
Oh my gosh! Yes,
they do.
They
do. He has this really, really amazing thing where all these LEDs are laid out in the Fibonacci pattern.
Yeah.
And they do really, really amazing things where NeoPixel-like LEDs. It's really fun.
Yeah, super cool. We love the Fibonacci boards. They're really, really awesome. And if you're into LEDs, you should definitely check them out. They're really cool. And
absolutely.
Really nice
he sells them on. He sells them on Tendy and Evil Genius Labs.
Evil Genius Labs, exactly. It says it right there. Go check them out if you like LEDs. Brett, following up from the CircuitPython question, says, where's a Tanu when you need one? I think he's preparing for his stream. His stream starts at in like an hour from now over on YouTube as well. So you should check out. He always does these really cool deep dives into different parts of the things that he's working on, which is super cool. The evil genius himself. Yes, it is. Here we are. And then here we are. We have a comment here from iShotJR saying, I want a CCC apron. I think we've just discovered some new swag
marketing potential.
Need. Yeah. Or maybe some new projects.
We get like circuit traces going up and down, and a nice like a black and blue or orange and blue, some cyberpunk-esque things.
I like it.
Be nice. Let's do it, David. You and me.
You weren't stealing any show, Jason. We're delighted.
That's what I was laughing at.
Oh my god, that's not even
everyone loves Jason.
That's not even a consideration. We're all hackers here. It's all good. It's all sharing. You know, we work in open source hardware. We don't mind sharing. I think that's a general rule. And we love your stuff. We love you. Big shout out to you, Fibonacci and Jason Kuhn. So here we are. So there we are. Oh, so Straith. Yes, Straith and Jason. If you didn't meet each other, you should definitely meet each other and cook up some ideas. Maybe wearing a CCC apron. Amazing. All right. So did you want? Gosh, how is it 5-1 already? How is that?
I know, right?
It's gone so quickly. What else do we want to talk about? There's so much. We can carry on. We can stay.
Well, does anybody? Do you have any questions about pick and place or how to start an assembly line or how any of that works?
I think we've covered the pick and place. Well, if anybody out there does have any questions, please, now is a good time to put them. But I also was really curious. I didn't even get to ask either of you about how you got started, which I love to hear from the guests on the show. So I know Joey spoke a little bit about some of your previous projects. I think the first project that I really became aware of your work on was the e-reader that you did. But it'd be really interesting to hear a little bit more about how you started out. Like, are you a trained electrical engineer? What's the how did you come into the world of open source hardware and start making your own things?
For my part, I was a software engineer and had never. Actually, it was frustrating because as a kid, I always wanted to build hardware. I had like little soldering kits that I didn't understand what they were doing. I found the remains of a 555 timer from when I was like 10 years old.
Wow.
But after later on, I just decided I wanted to finally buckle down and learn to make hardware. And the thing that got me really interested in it was Unicode and like building things that like spoke multiple languages and the languages of the world. And that's where the open book idea came from. Just building a gadget that could show literature in any language in the world. And so that was, I essentially taught myself all of this electrical engineering stuff just so I could figure out how to build the open book.
Didn't it win the Hackaday Prize as well?
It did, yes, it did.
Right.
Yeah, very exciting.
Happening soon, actually. That's SuperCon is just around the corner. I can't believe
it's next week. Yeah,
I was one of the judges this year on the Hackaday Prize, so I got to see a sneak peek of some of the things there, which was really awesome. And how about you, CCC? How did you get started? Like, how long have you been doing this?
My name's David. I started out doing after-school programs in 2019, doing electronics after-school programs, teaching soldering, things like that. Joey's in our classroom actually that we use to teach soldering and stuff. And I met Chris. Chris has a history in machinery and robotics. He has a machinist background. He can make any machine purr like a kitten. And him and I teamed up, bought some pick-and-place machines, bought an oven, got a building, hired a few people. And now we crank out stuff to help small businesses all across the world.
That's wild. So it's actually been relatively recently that you've been doing this stuff.
Yes, fairly new, and we're rocking and rolling.
That's amazing. That's really cool. And you seem to be working a lot with people in the community, people like Joey, people like Jason, you know, all of these things, which is really nice to see. It's nice. And also you get like the nice personalized, you know, it's like more of a personalized service as well.
Well,
you know, understand like the hacker mindset and like hacker culture, and it's really nice to have somebody within the community providing boards for the community, you know. So it's cool. I've been watching Cyber City Circuits and cheering you on from the sidelines. It's nice to see you up and running and actually really doing some really cool things. So nice job. Double thumbs up. And so. This is exactly my thoughts as well. So I shot JR has just said, I didn't know that was your first project, Joey, with a suitable emoji of a mind blown.
I will just throw out there
that I can't believe it was your first project. It's like
it took quite a lot of time for it to evolve. I think I will say it took quite a lot of time for it to evolve from like bodge wires and like a mess of solder to like what it became. So it was a learning process for sure.
Yeah, for sure. I mean, I can imagine. How long from the first time? So you had like the concept of the open book reader, and then you won that. You know, like how long do you reckon it took you that first project to get it out the door, to get it actually reasonably useful or usable? Like
from the first boards that I made, which was basically
just
you
had the idea. Like how long did it take you to get off your butt and actually start making the?
I would say something on the order of 2 years, because again, like it took a while for me to learn all of the skills I needed to learn. The first prototypes were just 3D printed things that would never in a million years work or be durable because I didn't know any better. So it took a while to realize, you can't just put something in a box with the wires. You need to actually learn real skills to make a thing like that. So it was a couple of years, but I feel like I'm a better engineer on the other side of it for, you know, all the mistakes made along the way.
Yeah, definitely. And and your sensor watch, this is going to be your first product. Is that right?
That's exactly right. Yeah.
And your
very
first
exciting.
Campaign with us as well.
First campaign, yeah.
Very exciting. Yeah, no, I'm excited. So how can people support you? How can they find you? How can they get involved in your work? You know, what? And that was a question for both of you as well. So, you know, like I'll ask Joey first and then I'll come to you afterwards.
For my part, I share my process on Twitter. I'm happy to I'm terrible at responding to emails, but I'm great at responding to replies. So if you have questions or want to have thoughts about the work, like I'm an open book with no pun intended. And I mean that's basically it. And then as far as the Sensor Watch campaign goes, sign up for updates on the pre-launch page because that'll be a way to support the thing and have one hopefully soon.
Yeah, and we are manufacturing the first 100 boards at the moment, aren't you?
That's correct.
Because you've got all the parts for that as well. What's the lead time like on the SAM L?
It's not as bad as it has been in the past. It's now down to June of next year, so it's.
All right,
it's still out there, but you've
got to get on it real quick, or to get part of the first batch. Is that what you're saying?
Right. That's the sense I get. Yeah.
Yeah. So you've got the first few, you've got the first few to hand, and then the rest will have to be ordered and made afterwards.
Yeah.
Exciting.
Early birds, and yeah.
Early birds, they get the worm, and the late birds, they have to wait for the SAM L to come in.
Here's the global supply chain to turn.
Yeah.
But I'm sorry, David, how do people want to support you? And yeah.
Sure.
Oh, yeah. Well,
My name's David.
You.
My name's David. That's Chris. We have LinkedIn, Facebook, all those too, but the real party's on Twitter.
Yeah.
And so we're Make Augusta on Twitter. Please follow us if you have questions. Our DMs are open. If you'd like to get a quote on any manufacturing, our email is sales@cybercitycircuits.com. That'll get you over to Angel, and Angel will take care of you.
Well, I hope to see lots more boards from the hacker community coming through Make Augusta as well. It'll be really cool to see that. Keeping it in the family. And Joey, it's now like we're over time. We've got to head off. But do you have any last words for the Sensor Watch?
No. I mean, unless anyone had any questions that they've had, but like I said, I share my process openly, and I'd like I welcome anyone with thoughts or questions to reach out.
Yeah, absolutely. And please, go along to the GitHub and contribute if you feel able to, and do sign up on the pre-launch page on CrowdSupply to be able to be the first in line to grab your Sensor Watches, because I think they're going to sell like hotcakes. I think people are going to be really excited to get their hands on them. Well, it's time. Thank you so much for a fascinating stream. I feel like I could stay on and talk to you for hours.
Let's do it.
Yeah, I know. We'll talk afterwards. It was really, really fun, and I really enjoyed seeing live a board made live. So interesting. We learned so much about the PnP and the assembly process during the stream, and we also learned so much about the Sensor Watch. It's such a cool thing, and I'm really, really excited to see what people start to do with it. And thanks to everybody for joining us as well. We had like a really amazing crowd in the house. You kept us company. You made us feel less alone, like we're shouting into the void. It was super fun, like super jam-packed full of really good things. So thank you to everybody. The next session will be again next Friday at noon Pacific. We will next week be talking to Joe Fitzpatrick, who is an awesome security researcher and maker of the T-Guard board. Which lots of people say is one of the most amazing debugging boards there. So we're going to be talking to him about security, hardware security, and all that kind of goodness. That should have been last week, but I was poorly last week. I had a cold. None of those. But yeah, so thank you so much for joining us. See you next week with Joe Fitzpatrick, and then future sessions as well. Lots of really cool things coming up. But yeah, mega thanks to everybody on the stream and all of the people who watched as well. Thanks for keeping us company. Bye now. Bye everyone. Bye.
Later.